Welcome, everyone. Super happy to be here today with Adi Polak. This is such an exciting episode. I have so many questions that I've prepared for you, Adi. I know you've been doing quite some podcasts lately, but first of all, Adi, how are you doing?
Well, first of all, thank you so much for having me today. I am feeling fantastic. It's summertime and it couldn't be better.
That's awesome. I'm super happy to hear that. For the people who might not know you yet, could you describe yourself in a few sentences?
Yeah, happy to. I've been in the data and AI field since more than a decade now. I've been working on both the machine learning side and also building data infrastructure side. I wrote a book on how to scale machine learning, who came out very in a very timely manner, where everyone are trying to scale inference and training, which is great fun. Also discussing deep learning and so on. I have a cat who might jump on the video to say hi. Um,
That's
yeah.
awesome. I really look forward to see that cat. And if you catch the cat in the video, for those who are watching the podcast with the video, let us know the time code in the comments, and I'll send you a surprise.
Perfect.
Awesome. So maybe if that sounds right with you, I would love to hear. So you mentioned you're writing you've been writing a book. You've had a very interesting career that I would like to ask you many things about. But first of all, today we're 14th of June 2023. I would like to know what what is your goal? What are you trying to achieve?
Wow, that's a really, really good question. What is my goal? So, somewhere midway into my career, I realized that education and everything around tech should be more accessible to people. So, my goal is to enable as many people as possible to get into the field of data and AI or data and machine learning by removing the boundaries and making it super simple for people to grasp sometimes hard technical concepts.
Hmm. Awesome. So your goal is very related to education and giving access to education.
Yes, and enabling people. Sometimes, we can read a bunch of papers and that could be super hard, and you need to do a thesis and have a PhD in order to understand a paper sometimes. So, really simplifying it, making
Hmm.
sure everyone can understand. Um, that's the
That's
goal.
awesome. That's so cool. I would love to ask you as my second question. Can you do a little bit of a retrospective of your career and like key points that have led you to today?
Yeah, happy to. I started going all in with a thesis in machine learning and working for in a lab in the laboratory with a bunch of masters and PhD students. All of us were doing our thesis and doing a bunch of research. And I was lucky to have my professor working with the field, so working with the industry. And so I got exposed to a lot of different projects. And it really taught me about how to go beyond just writing the paper and finishing the research, making it very, very practical. Like, how do we actually take it and then implement it for the company? So I did a bunch of projects for the Israeli Defense Force, for Fortune 500 companies, and so on. And I really got a good insight into, who is the persona that I'm building that model or algorithm for, how are they going to use it, and also what is going to be the business impact. Um, and this is something that I've seen a lot of researchers sometimes miss. It's like, it's great, we got a research out, we got a paper out, we got accepted into huge, huge conference, and we have a poster, which is fantastic. And then the question is, how do we make it practical now that we are out? If we decide not to continue um, in academy, like, now what are we doing? How do we make sure these things that we're building actually delivers ROI for the business? So that was very early on, and then I got exposed to the world of big data. Back in those days, we still named it big data and data warehousing, data modeling, all this world, which I realized that, hey, we have, when working with Fortune 500 company and really drilling into their data, it's a different challenge altogether. Like the first thing is I need access to the data. The second thing is, oh wow, so many problems, so many missing values. The structure is not right. There's a lot of work that is more kind of a software engineer or a data engineer, what we call today, that needs to be done before we can even, start doing anything that is a more of a research oriented. Um,
Mm.
and that was really a turning point for me because I realized that I can do all the great algorithms, ideations, research, insights in the world, but then if I don't have access to high quality data, it's it's a problem because I'm blocked.
Yeah.
Um, so that kind of led me into the world of how do we build data infrastructure, big data infrastructures that can actually delivers great quality of data and also enable the data scientist or the machine learning researcher to have that data available for them for research.
Yeah.
And it was a different conversation altogether because suddenly I've been on the other side of the table,
Mm.
right? I've been a software engineer, building the infrastructure, understanding the language of the data scientist, and building tools and building services for them, kind of to bridge the gap and making sure we're still building something that is tangible and delivers ROI for the company. Because I've been working in a company at that time. And it wasn't easy because there's a huge skill gap for a good reason between software engineers and data scientists. Um, Data scientists have this fantastic, phenomenal understanding of, the domain and the algorithms and statistics, but they completely miss on software engineering skills. It's not because they can't; it's just because, this is not something that anyone ever asked them to
Hmm.
take on. It's like, oh, now I need to learn how to better model my data so I can get faster access to it when my machine learning is doing its iteration during training. Now it works faster. So that was a really interesting conversation to have, and also how do we do feature engineering in a better way, how to work with the systems, how to leverage staging environment, also how to leverage what exists in the organization as well, because as a data team, so it goes beyond just data scientists versus data engineers. Actually, a data
Yeah.
team, everyone needs to collaborate and work together. Um, the data team usually serves more than just the data scientists. So at that point, a lot of the data scientists were brilliant to start learning the tools that we used in the data team and saying, oh, okay, now I don't have any knowledge of Apache Spark, for example, but maybe it's a good idea for me to start diving into it because I see everyone here in the company is using it. And if I want to get access to the data, I better learn it. Um, and so this is how it began. So I created an in-house course to train everyone. It was tailored to data scientists, and then actually the chief architect joined, and a bunch of other folks joined. I was realizing, oh wow, you know, this is bigger than just this. There's like a huge skill gap, and everyone wants to better understand what it is that the data engineering are doing, and how to optimize it and how to leverage it, because that gives them access to data and the ability to process the data. Because there is a cluster in place, right? We're already managing the cluster and making sure it has good performance. Um, and that was kind of a very interesting insight into dynamics of a company, dynamics of R&D team, how to work together, and really, understanding of the needs that these things should be simplified so more people can get access and, you know, better tools also. So it was a lot of very interesting insights that I learned, and also that took me um, some time to put everything together in a book that just yesterday crossed 1,000 people that bought a copy. That was fantastic.
Congratulations. That's
Thank you.
awesome.
Yeah, 1,000 copies were sold, which I'm very happy because it means it serves people and people are interested in this, and it really solves a problem. Um, Yeah, and I'm doing a lot of, since then, I've been doing a lot of public speaking, creating content. So more and more people outside of the organization that I work for can learn and grow in their field. And we've seen, Apache Spark explodes and TensorFlow explodes and PyTorch explodes and all these fantastic technologies today.
Hmm.
Um, yeah.
That's awesome. That's such an amazing journey. Um, and I have so many questions on each part of this journey. Um, but you said something about that about software engineers and data scientists. If I'm not wrong, you started as a machine learning researcher, and then you went for a software engineer job, right?
Hmm. Yep.
And then you grew up. You work a few years at Microsoft. Is that correct?
Yes.
And so my question is two in one question. Everyone knows I love to do two questions in one, but you mentioned about the difference between software engineer and data scientists. So
Yes.
could you state maybe a bit of what is good about a software engineer that is missing in a data scientist? And same question, but the other way. And further than that, how did your experience at Microsoft change your vision or impacted your career?
Yeah. Um, well, there's a lot of best practices that comes from software engineering that I believe a lot of data scientists can leverage for better collaboration.
Hmm.
Um, using a proper IDE with everything that they need, plugin, using a cloud service to train their model so they can actually train at scale and get access to all the hardware that they need. I've been working with some data scientists who always purchased new processors. And today, actually, there's a cloud. So you click a button and boom, you have this new NVIDIA GPU
Yeah,
processor to take advantage of. Of course, you need to limit the bill because it is
exactly.
there's a price, but it's much faster than going and try to shop for a new GPU and then installing it and going through that process.
Yes.
So definitely leveraging the cloud, definitely going beyond one's laptop is critical. And this is something software engineers are doing frequently when they develop software. They have their own environment, dev environment in the cloud, they have the staging environment, and so on. So, just some of the things. There are many more practices around testing, reusability of code, um, clean code, uh, a bunch of them to make sure it works. Using tools that are already scalable so they can later on take it into a staging environment and into production and not just scripting something and putting it together in Python without the ability to later go back and revisit after 6 months. It's like, oh, people forget what they did. So it's better to have it in a way that it's clean, well organized, so they can go back and revisit what they did, and also their team can collaborate on that. On the other side, from data scientists to software engineering, there's a lot of things to learn around statistics and around um, domain understanding, having a good understanding of the domain. So for my thesis and a lot of the research I did, I worked in the cybersecurity domain, which is a very specific domain. I worked with network traffic and system calls. And after that, I went to do software engineering again for a company that build, infrastructure and tools for security purposes for their networks. So it worked really well in terms of understanding the actual use case and what is the data that we're dealing with. So data scientists usually understands the domain better. They understand the problem space better because this is what they do. They need to do the research and develop something that would solve this problem or automate a process. And software engineers don't always have the time to do that. And sometimes, depending on the use case, this is like a big caveat here. It's like really depends on the use case. If they will know the domain that they are interacting in, they can sometimes develop a more efficient software, more efficient code, because they would know the edge cases better, and so on. So, for example, if you work with networks, IPv4, IPv6, how do you filter? What do you do? Um, and understanding how IPv4 and IPv6 behaves can really help software engineers. And again, it's not something that is not accessible to learn. It's just a matter of saying, okay, I'll dive into it so I can better understand instead of, asking for full definition of what this software needs to do, including the patterns matching and so on.
Hmm.
Um, yeah, or detecting, credit cards over the network and things like that. That sometimes when you create a software that defends a network, you need to do. Um, yeah, these are some of the things. And then you had another question, which I forgot.
Yeah, sure. No, thanks first of all for this question. And my other question was related to your experience at Microsoft and how it impacted your career.
Yeah. So Microsoft is a huge organization, and different people find themselves in different places. For me, I worked very closely with the product teams, and that really impact my career because I got insights into how product teams develop strategy, how the business looks like. How do you develop more impact? How do you build a work plan that is tangible but still make it very agile? Um, so, you know, under commit, over deliver. This is usually what big corporates go for. It's not necessarily true for small startups or the stage startup, but big tech are usually going, or big startups also are usually going with that approach. Um, so, how to build a road plan for 5 years, how to develop a strategy, how to develop a mission, a vision, values for the team, knowing that the values could change according to what is needed to achieve. Also, was a big thing that I learned, and I worked with some of the best, and developed those things also. Um, so it gave me uh, a better view of the whole system. And Microsoft has a very interesting approach. It's like, not one team is developing everything. It's like one team works on one product. And then there's hundreds products that, the company is building. Like there's a huge portfolio of products. Some of them are internal products that serves internal R&D and internal stakeholders. Some of them are external that serves the population and the Microsoft customers. So it was really interesting to see that diversity in that portfolio.
Mm-hmm.
Everyone today, and Microsoft CEO also speaks about it in very, you know, he shares it a lot how diverse Microsoft investments are, and I believe, especially during this type of market, making sure you're diversifying your investments as a company is key. And I also got some fantastic insights from executive on how they build their portfolio, how they're managing their budget. It was super interesting to learn. Um, yeah, and managing a team. It was the first time I took on a team. And Microsoft is known to have one of the best training for managers in the world. Um, it's 6 months, but then it goes like it continues. So it's very, very interesting. It's very intense. So I learned a lot about managing a team, building a system, how to build trust, how to make sure everyone's collaborating and delivering impact, how to make the tough conversations, how to give feedback. Um, you know, everything that comes with management responsibility, how to manage up, and so on. So it was very good experience. Highly, if people have the opportunity to join one of the big tech because they want to learn how things are getting done at a massive scale and want to get hands-on training and um, work with some of the big some of the smartest people on planet earth. I highly recommend it because it's really is different than anything else I've seen.
That sounds wonderful. Thanks for sharing this journey, and I like the fact that you really highlighted um, all the learning that you got from working at Microsoft, and it really enhance what people should be looking for to learn at the beginning. Well, the beginning and in their career, I feel, because each of those points we always tend to talk about like technical aspects of things, but you mentioned so many valuable points like planning management and so many other things that you mentioned that I felt were very valuable. So thanks a lot for sharing. Now I'll just dive right into another subject, which is your book. We can see your book just behind you if you're watching this podcast with the video, with the little Groot. Love Groot, by the way. I mean, who doesn't, right? So
Hmm.
your book is called Machine Learning with Apache Spark. What I would like to ask you first about the book is, what can people um, look for in the book? Because you mentioned about your journey and what you learn, and we know that the name of the book is like, okay, it's Spark, but it might also have a big part of what you've learned, your journey, and so what can people expect from this book, and how could it help them achieve better systems at scales and more things?
Yeah, so it goes way beyond Spark. Up until probably the midsection of the book, I talk about Spark, explaining how things work, what type of deep learning can you do with Spark, and also what's the limitations. Because being very frank, this is there are some limitations, and we should be aware of that when we're choosing and working with the technology. Um, and also discussing how to manage kind of end-to-end machine learning workflow, which is critical because if we don't think about the end-to-end, we will never reach the stage of actually having our model in production running and serving our customers. So having that in mind, building a plan, working towards that is also very critical. And then I'm diving into more advanced topics while showcasing with code samples and deep explanations on how to work with text and how to work with images. There are more on the deep learning side of things. Also, how to, what are ensemble learning? That is a more advanced topic of the machine learning space. Dimensionality reduction, um, random forest, gradient boosting, and how to do distributed training with TensorFlow and PyTorch. And I've been told that it's probably the first book that actually covers that because there's not a lot of knowledge out there on how the distributed TensorFlow works and how to go about that. Either if you're doing data parallel or you're doing algorithm parallel, if you need to have billions of parameters or what's not. It dives into those to make sure the readers can apply those techniques as well as they grow and develop in their career. Um, and it was also kind of a journey I went to, and also I worked with some customers that are still going through that journey. And actually, just last week, I had a conversation with a CEO of a super interesting company that are processing images. And he said, we needed that because we work with Spark, and now we also want to add PyTorch on top of that. So and we couldn't find anything. So I was like, okay, I'm excited that it serves you, when he bought a copy for everyone in the company, which was uh, really great to hear that it's helpful and it's useful for them. Yeah, and lastly, the book finishes with the different deployment patterns and observability. How do you
Hmm.
observe your model in production? What is data drift? What is concept drift? What are the different statistics, measurements that you can do with sliding windows in order to understand if that's the right time to, reiterate your model and get a new model in place? What are the pros and cons of deploying in real time versus deploying in a batch? Deploying it on one machine, or as part of an existing service or as its own service, right? We've been using a lot of things like OpenAI, cognitive services, and so on. We know we interact with these APIs because they are deployed as a service. So how do you create that inference and still making sure you're serving, the user, while understanding that there is inherited difference between the hardware sometimes that you need also. um, so really diving into all the things that are important and sometimes people are missing when they develop their plan or their strategy in order to build the services. So really taking another step in. And I guess what's interesting about it is this book started at 2019. uh, and it came out just when AI is booming again, and actually, it's important to be able to scale your machine learning applications either for inference or for training. And it really shows that, kind of as an industry, I believe we're kind of in a cycle of data and AI. And it was data a year ago, but now it's definitely AI. How do we enable it? Where the application that we're building, um, models now, or a lot of them are open source, which is great. So now we're actually looking at the more the end-to-end machine learning workflow, going beyond just the training, because we have those. How do we take it into the next step? Like, can we take an existing model? If it's a deep learning, right, we have our neural network. We can add our own layers, right, on top of them. So we can actually take existing model and say, okay, I just need to train that one part in order for it to fit my uh, business problem that I'm solving. So how do we do that, and how do we take it into the next step? Um, yeah, and it was a really great journey writing that book, and I'm really thankful for tons of people that did review and gave constructive feedback and made sure to that it's actually written in a simple way. So I had an interesting mix of reviewers. Some of them are more advanced, so I make sure everything is tangible, it's accurate, and so on. And some of them are more new to the industry, to make sure it is accessible.
Hmm. Hmm. That is super interesting. To be honest, I have so many questions in my mind that I'm not sure where do I want to go right now, because you mentioned so many things that fascinates me. Let's start with you mentioned observability, and we're going to do an episode beginning of July with Andy Petrella. I think that you've talked with him for the review also of this book, but also he's going to release his book about observability. So we'll discuss that with him further. So I won't ask you about observability, except if you want to mention something. Um, you mentioned so many great topics. So I feel like what I would like to ask you about is how do you get the knowledge and expertise to talk about all of this and capture the big picture while being specific in each of you mentioned you focus on deep learning, such as dealing with images, texts. How do you get to a point where you have enough of vision on the field and the industry to be able to write all this expertise. And let me push this question forward. Like, how do you approach, because you've been a search, you've been working in research, but you've also been working with products you mentioned earlier. So how do you combine the practice and experience with the theory, and like how do you approach learning new things?
Yeah, so combining practice and theory and approaching learning new things. Um, if there's something that been guiding me since the beginning of my career is openness and learning. I believe from every person that we meet, anywhere, everywhere we go, that we can learn something new from that individual. And it could be someone who is educated, not educated. It doesn't matter, who they are, what they do, and so on. There's always something that we can learn from them and grow as individuals. So this is a practice I've been taking with me, throughout my career since forever. And I'm considered a very good listener. So I gained a lot of knowledge myself doing hands-on practicing and also learning from others and collaborating with my team, with external folks, and so on. And being open is not being blocked in your head by saying, "Oh, this is the way it should go." There are other ways. There's pros and cons everywhere. There's always a risk management and another way to do things, which I'm a very strong believer in, and taking those two characteristics and being able to do a zoom in and zoom out into what exists in the industry, where are we going, what exists in the company that I work for, what's the strategy, why is the strategy the way that it is, what did we learn from other companies, what did I learn, from my colleagues or previous colleagues in the field, really gives me a big picture, and so I'm able to zoom out, take a very very far zoom out, and then also zoom in into the nitty gritty of details, and kind of tell people, oh, your SQL query here could be improved by so and so. And I believe this is something that people can practice. The more we do it, the more we are open to hearing, what other people are saying and joining, all the whole hands meetings and really listening in to, what management is saying, what individuals are saying, can give us a lot of insights into where the company is heading and what is going on in the market.
Mm.
Um, and understanding that, if we'll dive into specifically the machine learning space, what's happening today with LLMs, LLMs are a subset of NLP, right? Natural language processing, um, which is a subset of deep learning, which is a subset of machine learning. So, once we understand that there's a huge boom in LLM, which is a subset of something very specific, it means as an industry, we're kind of really diving deep into this space of large language models, what they can do for us. And if we'll take one step back and think about NLP, there's a lot of other use cases with NLP that we can think of and say, oh, there might be another opportunity there, or there might be something that we're missing. And if we'll take another step back, we'll look into the deep learning space and we can say, oh, there's also a lot of work with images and videos and, detecting things in images and extracting, people's sentiment and doing a lot more work on top of that, um, which could be maybe the next thing, right? We've seen the autonomous cars exploded some years ago, and now everyone are kind of like heads down doing the research, continuing to developing the algorithms. And probably soon we'll see another huge progression in that field. So that gives us kind of like the big picture. of what machine learning is, and then we know that garbage in, garbage out, right? Or with data. So we know another big part of that whole revolution is access to data, so we can
Hmm.
actually train the model to do things. And so diving into the data, we can find different aspects. It can be structured, unstructured, semi-structured. It lives in a data warehouse. It lives in a data lake, on object stores. It lives on my laptop, on my file system, right? Anywhere in the world I can capture data. There are applications that are more data hungry. And we can really dive deep into those and try to figure out how can we build the bridges between them. So it gives us kind of, it's enabling us to do, take a step back, look at the big picture and saying, okay, this is, now that I understand that these things are subset and these things collaborate together, now I kind of have these two universe of machine learning and data, but there's a good in, they're lapping, because we can't work with machine learning without having data. We can work with data without having machine learning, but machine learning can make it much easier for us sometimes to automate process and so on. Um, so once we understand that space, everything that we do, we can always think through and say, now I'm working on that specific logic, on that specific Spark job or application. How does it fit with, the bigger picture of the world of where we're heading towards?
Hmm.
Yeah. So, being able to understand that, um, and be curious around that are some of the, I highly recommend it to people, even though sometimes I know work can be daunting and sometimes we're developing the same things. And we work with tons of legacy code because this is the way we do it. Um, Still, there's a lot of opportunities in everything that we do if we'll open our mind and say, okay, now I'm curious about what's going on here. I want to know more. I want to learn more. Um, yeah.
That's awesome. A lot of um, a lot of things to take into consideration, but not losing the big picture is a big part of it. That's fascinating. Um, the complexity about asking questions on these kind of topics is that it is so large that we will need to take each specific use cases to like dive into it um, and understand every aspect of a project, such as data architecture. Then how do you do data engineering, and how do you like which compute instance do you decide, etc. But that being said, I have a very specific questions that I would like to ask you. It's about prioritizing. So let's say I'm a little startup. We're kind of growing, or I am a company that is close to reaching market fit. For each scenario, there are different plans. How do you go about prioritizing in scaling your data architectures, your all your services? How do you what would you recommend? Like, how is the approach to say, okay, now we're going to open new instance, now we're going to open new machine learning use cases, now we're going to do this because it is the right time? Maybe a tough question, but I would like you to ask that. How do you prioritize this process?
Yeah. So let's make sure I capture it correctly. We are a small startup now. We're close to reaching product market fit. And now we want to prioritize some of the work that we do around scaling, architecture, and so on, right?
So if we're going to take an example in particular, I was thinking like, no matter where we are, like how do you figure out, even if like I'm a big company or I'm a little startup, like what is the is it the same process to prioritizing my scaling, even though like it's not the same components? Like, do you think this is a question you could answer, or should we like take from a specific point and then grow a case?
I think we can generalize it and maybe we can dive, as we go. Because
All right.
There's different approaches that were developed in software engineering and R&D as a general. One of them is waterfall. When I have my
Yeah.
big plan, I'll just going at the plan, knowing that this is the best plan that you can create on planet Earth. I have, all the oracles supporting me, and so I know exactly what to do and where to go. And I put together a long-term plan, and I don't need to iterate on anything. So this is the waterfall, and waterfall kind of became outdated some years ago when we realized, hey, we need to move faster, we need to learn from every iteration, and we need to do retrospectives. And so we reached the stage of agile and scrum, where actually we're building it on top of very small iterations of usually 2 weeks. And every time we do a retrospective saying, what did we learn during this time? Are we heading into the right direction? Do we actually need to scale our infrastructure? And heading into the right direction for a small business or even in a big corporate, we're just building a new product is, do we get traction? Are people interested in the product? Are people buying our product? Do we have new customers? Because I'm not going to open another region of my product, right, on the cloud, and cloud regions, just for the sake of having that region if a potential customer would use it, because it's going to be costly. It means I'm paying for more machines. I'm taking all my infrastructure. It's great that my infrastructure is repeatable, right? I've used TensorForm, and everything that I need, Terraform, sorry, and everything that I need in order to make sure my architecture is repeatable. But then actually deploying it means I'm just paying more money for cloud services without customers leveraging my infrastructure. Um, so this is a very solid and important point to take into consideration. If there's no customers, I don't need to scale my service. I need
Hmm.
to have something that works. I
Hmm.
need an MVP, a POC, something that looks good,
All
but
right.
yeah, works in my machine. One machine doesn't need to scale, but it's accessible. And once I'm starting to onboard new customers, I can start scaling it according to my customers' needs, right? So I'm tailoring it in a way that my customers are happy, and they have the throughput and everything that they need for it.
Hmm.
So this is one thing about infrastructure and about scaling. Um, when talking about machine learning, I guess this is slightly different because scaling machine learning can be also scaling the training, which means I have lots of data and lots of parameter to train my model. And then there's the inferencing. So if I have no customers, maybe I need one instance. So when people are checking out my platform, they have access and they can say, okay, this is something that I want. And so how do we get on board full time and take it to the next level of actually using it? So this is when I need to look into inferencing at scale. So now I need to serve more customers, and so my model need to be deployed in a way that it actually available for the customers when they need it. So this is a slightly different conversation altogether. Yeah, so I highly, agile, I believe, is the better way to go today, and sometimes even if we wanted to drill down into smaller granularity, I would even go with experimentation. Like 2 days, one day, let me just see that, what I build with Terraform, actually, I can deploy it on that region. Okay, cool. I deployed it. I got something into the system. Now I'm turning it off because I don't want to incur all the cost of actually keeping the lights on for something that it's not being used.
Hmm. That's super interesting. That's super interesting. Um, I mean, I could go on and on and on. I think I'll do one more question regarding this, and then I will do the three little questions that I always do at the end of the episode. Um, and not that I want to shorten this episode, but I know you have other meetings to attend. My question is, and thanks for sharing like how to approach scaling. And you mentioned like having an agile approach, doing sprints of like, for example, 2 weeks. Of course it changes based on what we're doing and what we want to achieve. My question is, how do you define the right KPIs to monitor to evaluate what we're doing? And I know this could be a question like to be answered in like 2 hours when we can do an episode only about that. But maybe can you share some insights about KPIs?
Yeah, wow. So there's a whole philosophy around OKRs and KPIs, where OKRs are more kind of like high level and KPIs are very metric driven. You need to see the numbers, you want to see the graph of growth, and so on. There are lagging KPIs that we cannot control directly, right? I'm developing something, but then, hey, there's no customers. So it's kind of like a lagging KPI if I don't fully responsible for bringing in customers, for example, and closing deals. Um, so I believe it's something also that's important to track, but yet again, it's a collaboration between management and leadership around who owns which KPI is a lagging KPI, and which KPI is something that we can actually control. um, and also seeing the connecting point. In R&D, we can develop lots of code, but then the question is, does it actually serve the customers in the way the customer expect to be served, right? Um, and if the answer is yes, this is great. But if the answer is, we build a bunch of infrastructure for the sake of building a bunch of infrastructure, then there is some productivity challenge, because at the end of the day, R&D needs to deliver impact, needs to make sure they're building it for customer, and still it's kind of a combination between short term and long term. Short term, making sure customers are onboarded and happy. Long term, the future customers are going to be happy also, and onboarded is going to be easy to, or simple to manage the software and the infrastructure as well. So KPIs are very interesting. I always look at lagging versus at KPIs that were impacting. And also, there's a notion around operational KPI. So, when you build a system, you need to think about the different pieces of the system and how those impact the end results. And so, this might not be, the KPIs that people say, I'm measuring it on a daily basis, but it can, especially for long term
Yeah.
KPIs, it can give you a better understanding if you're heading into the right direction or not. Because if those are not changing, maybe you want to change the activity that, the task that people are working on, and actual, activity that the company is doing, change direction to make sure it is, being addressed and you're actually heading into the right direction.
Thanks you so much, Adi, for sharing all this knowledge. I think we could go on for hours. I have so many questions about both the book, your career, your vision. Um, yeah, your journey is very inspiring. So thanks a lot for coming on the show and sharing with us. My last two questions would be, how can people contact you and like access the book or your website? Like, where can people reach out?
Yeah, so LinkedIn is probably the best platform to connect. I'm also available on Twitter, but then I can be a little bit slower to respond. So if you want to connect, happy to connect over LinkedIn. If you have any more questions, things that you want to dive deeper, would love to share what I know. And for the book is available on Amazon. You can get, ebook edition, a copy, and also, if you are in Data and AI Summit, I'll be doing a book signing. So you're most welcome to come say hi, and I'd love to give you a signed copy of the book.
Awesome. And last question, Adi, would you have a message for the Let's Talk AI community, for people who are listening? Any kind of message. It can be personal, it can be professional, it can be whatever you decide.
Yeah, think big.
That's it. Thanks a lot again for coming on the show, and have a great day.
Thank you so much, Thomas. It was great.